Hi, I'm Eugene. We are Group 3, and this is our OOP project part 2. In this project, we'll build a 2D educational platformer game designed to promote healthy eating habits using interactive gameplay. Here's a quick overview of what we'll be covering in this presentation. We'll start with a brief introduction of the game and the problem it tackles. Then we'll show a demo and walkthrough of the gameplay. After that, we'll cover key aspects of the game engine, improvements from the previous submission, and how we integrated AI usage in this project. Let's begin with the introduction. Let me walk you through a quick introduction to our project. The problem we'll be addressing is a rise in unhealthy eating habits, especially among young people. Traditional methods of teaching nutrition can be often dull and forgettable. That's why we saw a need for something more fun and engaging, something that could actually hold attention while delivering a meaningful message. The objective of our game is to promote healthy eating habits in a simple, interactive way. We want players to naturally learn which food are good and which are not just by playing. In terms of gameplay, the concept is straightforward. It's a 2D educational platformer where players collect healthy food like fruits and vegetables to score points. Unhealthy food, on the other hand, reduce lives and slow the player down. To keep the experience fun and not too punishing, if a player falls, they respawn at the last save platform. So overall, the game blends learning with entertainment, encouraging better food choices through enjoyable hands-on gameplay. Next, we'll proceed to demo and walkthrough.
Hello everyone, today I'll be doing a live demo and highlight the features of our game. So launching the game, the user is presented with a start menu screen with a play button and a how to play button. As you can hear, there's also background music in the game, and later on, we can also hear the sound effect in the game. Clicking on how to play, present the user on how to play the game. Arrow keys on the keyboard to move and spacebar to jump. The game also have a point system. Healthy food give the user 10 points and unhealthy food decrease the user's life points. There's also a time system that is counting every second and is paused when the user were to lose a life and is presented with a fat screen, and is resumed if the user were to return back to the game. So once the user collide with a healthy food, a screen presenting the facts on healthy food is shown to the user and is closed if any key were pressed. And if the user were to collide with an unhealthy food or fall off the platform, the user will lose a life and go back to the start of the game, this time with a slightly slower movement speed. Let me demonstrate it. So you can see at the top left, my life has decreased, and if I have to fall off the map, my life is also decreased. When the user were to lose all their life, let me demonstrate. The game will end. As you can see from the game ending screen. So that's all for the live demo. Let me pass on to my teammates to talk about game design and the problem it addressed.
Hi, my name is Samuel, and today I'll be talking about our general game design and how it addresses one of the problem statements in the guidelines document for Team Project Part 2. We decided to address the statement on educating families and parents about healthy eating, more specifically focusing on teaching children on healthy eating. We felt that it's important for them to learn and instill good eating habits from young, as their bodies are still growing and developing. Eating healthy food plays a big part in their bodies growing up healthily, physically and mentally. For example, eating healthily helps with brain development, helping them focus better in school. It also helps boost their immune system so that they won't fall sick as easily. Furthermore, this also lowers the risk of long-term health issues, such as obesity or diabetes cropping up in their adulthood. And when kids start building these habits from young, they will find it easier to stick to them into adulthood. We decided on a platformer that you've seen earlier in our demo, as it is familiar to kids and easy to pick up and play. It rewards the player for picking up healthy food with points and tips. These tips, as shown on the right side of the screen, advise on what benefits each food in real life gives if you eat them, such as apples support gut and heart health, or broccoli helps detox and may fight cancer, so that kids would know what they should be eating and what is considered healthy foods. Parents can also benefit from these tips as they apply to all ages, making them aware of what them and their kids should be eating. Conversely, eating unhealthy food punishes them by making them lose a life. Lose 5 lives and they lose the game. We hope that this will teach kids on what foods they should eat, how it benefits them, and what foods they should avoid. I will now pass the time on to Joshua to discuss about our game engine.
Hello everyone, I am Joshua, and today I'll be presenting the key aspects of our game engine, focusing on 3 key aspects: scalability, reusability, and design. Scalability is crucial for a game engine because as a project grows, it needs to handle more objects, physics, and interactions smoothly. Our engine supports scalability through an entity component system, allowing us to easily add new game objects. It also includes scene management for structured game flow and collision handling to efficiently manage physics calculation. Reusability ensures that our engine's components can be used across different projects without rewriting code. The abstract engine core provides a solid foundation for multiple game types. Scene lifecycle management ensures seamless transitions and customizable collision strategies, allowing developers to adapt the engine for various needs. Our game engine's design is structured around a clear architectural approach. The entity component architecture ensures objects are highly modular and reusable. The scene and lifecycle management system provides structured transitions between game states. Finally, our collision system follows a flexible design, allowing the integration of different detection methods. Our game engine is designed with scalability, reusability, and maintainability at its core. It supports expansion, making it adaptable to various game genres while maintaining performance.
My name is Jarek, and I'll be covering the slide on the improvement from previous submission. Based on previous feedback, we've made sure to adhere to the solid principles as well as the pillars of OOP moving forward. For starters, we split the exception handler into separate classes, tackling the single responsibility principle and the dependency inversion principle. Movement and collision managers are also now more easily extendable and modifiable, which conforms with the open-close principle. And interfaces are also added to support AI and player movements, to adhere to the interface segregation principle, as well as to tackle the abstraction pillar of OOP. Lastly, entities list is also now properly encapsulated. Some new things we've added is the implementation of 2 design patterns, Singleton for Audio Manager and Factory for Enemy Class. We chose to use Singleton for Audio Manager as the game requires global access to it, be it when player collides with enemies, collects items, or falls. By using Singleton, we avoid passing the Audio Manager reference through multiple classes and methods, which simplifies our code more. We've also used Factory for our enemy class to centralize the creation logic of different types of enemies we have. Using Factory allows us to support different enemy types with one class interface, making our code simpler again. A few of the other things we've also added would be our menu screen with the how to play and objectives added in for context to players. Audio, as mentioned before, was also added in to make it more fun and engaging for the players. We've also added in fact sheets that pop up when players collide with their healthy food, educating them on food nutrition while experiencing the game. Lastly, it wouldn't be a game without the integration of a score system, a timer, and a live counter. With that, I'll pass the time on to Nurul on the usage of AI in our project.
My name is Aida, and I'll be talking about our AI usage using GAI Team for this project. There are a few contributions that GAI has made in improving our game's maintainability and scalability. I'll be going through those that we have implemented. Firstly, we have the singleton pattern. We implemented this for our audio manager to ensure that there's only one instance throughout the game. This centralizes audio control and resource management, preventing conflicts and ensuring that all audio is handled consistently. It's a simple yet powerful approach to managing shared resources. Next, we applied the factory method for enemy creation. This pattern allows us to add new enemy types without altering the existing code, which enhances our system's flexibility. Another important aspect of our implementation is component grouping. We organize components by functionality, such as rendering, physics, and audio, by game entity like players and enemies, and by system including UI and networking. This approach ensures our code base remains clean and scalable as each component has a clear responsibility, making maintenance and future enhancements more manageable. Additionally, we reviewed our two-layer architecture, separating the engine layer from the game layer. This structure has proven to be effective for our current scope, but as the project grows, GAI suggested to introduce additional layers of AI, networking, or UI if needed. Lastly, the practical coding examples we explored for the singleton and factory method patterns have been especially helpful in integrating these ideas seamlessly into our project. In summary, by adopting these patterns and organizational strategies, GAI has helped streamline our development process and build a robust, flexible foundation for our game. Thank you.